Welcome to my KTM video playlist. Today we are going to solve one problem that is based on multiple plate clutch, which was asked in university examination. So let's see carefully. First of all, see the description. A multi-disc clutch has 3 discs on the driving shaft and 2 on the driven shaft. So here you can see this is the driving shaft and this one is the driven shaft. So here you can see there are different discs on the driving shaft as well as on the driven shaft. The outside diameter of the contact surfaces is 240 mm. So here you can see outside radius and inside radius. So here it is given to you, assume uniform wear theory. So only you have to apply one theory, that is uniform wear theory. And coefficient of friction as 0.3. Find the maximum axial intensity of the pressure between the disc for the transmitting 25 kW power at 1575 rpm. So let's write first of all the given data in symbolic notation. So here it is written, multi-disc clutch has 3 discs on the driving shaft. Whenever it is given to you like disc on the driving shaft and disc on the driven shaft, so you should write N1 and N2. So N1 is equal to 3, that is on the driving shaft, and N2 is equal to 2, that is on the driven shaft. The outside diameter of the contact surface is 240 and inside diameter 120. That means you can say D1 and D2. Next, assuming uniform wear theory and coefficient of friction, so mu, find the maximum axial intensity of pressure, that means P. So P, that is our objective. For transmitting 25 kW power, so P is given to you at RPM, so N. Now here, you know that power transmitted by the clutch plate is P is equal to T into omega. Here you have the power and you can find the omega also, but you don't know the torque. So you can apply this equation, torque T is equal to N into mu into W into Rm. And for the omega, you can apply this equation, omega is equal to 2 pi n upon 60. You have the value of N so that you can find the omega. But here you don't have the W as well as Rm. But you know that for the W, this is the equation, and for the Rm, this one is the equation. And both these equations are actually for the uniform wear theory only. So this is the simple introduction of the planning of the given problem. Now here, this C is the unknown parameter, because of that is not given to you. But you know that for the uniform wear theory, P into R2 is equal to constant. This is the equation. So you have to remember, if uniform wear theory is given to you, then definitely you can say P into R2 is equal to constant. So now based on this planning, I can solve the problem. But before that, you know that this is the torque transmitted capacity where Rm has 2 different formula. This formula that is for the uniform pressure theory, and this one is according to the uniform wear theory. Here we have to apply the uniform wear theory so that you can find Rm from this equation. Now here I am going to find first the omega, that is 2 pi n upon 60. RPM is given to you as 1575. So put it over here so that you can find the omega, that is in radian per second. Now you know that power P is equal to T into omega. We have the power, so you can put it over here. But you know that power for this formula, that is always in watt. So convert it into watt and put it over here. Then T is the unknown parameter. Omega, you know that is 2 pi n upon 60 and that is equal to 165. Simplified so that you will get the torque. And you know that for this equation, torque is always in Newton into meter. So I have written over here torque is equal to 151.5 Newton into meter. Now you know that number of pairs of the friction surfaces, that is n is equal to n1 plus n2 minus 1. So you should remember this formula whenever n1 and n2 is given to you. Now put the value of n1 and n2 both over here and simplify it so that you will get the number of pairs, or you can say effective pairs. So I am going to write n is equal to 4. Now next, you can find the mean radius because of you have the r1 and r2 both. So put it over here. R1 that means d1 by 2 and r2 that means d2 by 2. Simplify it so that you will get Rm, that is in mm. Now you can use this equation, torque transmitted, that is equal to this one. Now put the value. So now we have the torque, that is 151.5 Newton into meter, is equal to n, that means 4, mu that is given to you as 0.3, w is the question mark, and rm that means the mean radius. But here, very important point, here rm that is in mm, but you should put the value over here, rm is in meter, because of in this equation torque that is actually in Newton into meter. Here you can see. That's why I have converted this rm in meter also. So keep in mind, unit must be the unique for the torque as well as Rm. If the torque is in Newton into meter, then it must be in meter. If the torque is in Newton into mm, then Rm must be in mm. So you can select anyone. Here I have put Newton into meter so that it is in meter. Simplify it so that you will get W is in Newton. Now you know that axial thrust W is equal to 2 pi c in bracket r1 minus r2, that you can see over here. So put the value of W as 1403, 2 pi c as it is. You have the r1 and r2 also. So simplify it so that you will get c. So once you have the c, then definitely you can use this equation. P into R2 is equal to constant for the uniform wear theory. Now put the value in this equation. So P is our objective. R2, that is d2 by 2, is equal to C, that means 3.72. Simplify it so that you will get P. This is the intensity of the pressure, so that the unit is Newton per mm square. And this is our answer, maximum axial intensity of the pressure. So make a box. So again, this is very simple problem. If you have any doubt, then write in the comment box. Thanks my dear friends for watching this video. Press the like button to appreciate.